If we think about the previous exercise and the need to move the contours to conform with a 5% constraint, think about how we needed to do certain steps. So the very first step was we needed to determine what the existing slope was. So recall, in order to do that, we need to do a little bit of math. So up here towards the top we have step 1, determine existing slope. So slope equals rise over run. And what we're going to do is we're just going to take, we already know that this is 10 feet across here, because we're given a scale down here at the bottom that says each of these little engineering paper squares is about 5 feet, so 2 engineering squares apart is going to be 10. So we're just going to look at the spacing or the dimensions between two contours. So we don't really care, what the specific elevation value is, because we know the elevation change is going to be 1, and that's all that really matters. But we do need to make sure that everything here is equally spaced. So everything here is 10 foot spaced across. We kind of have a uniform slope across here. So constructing our triangle, we have 10 foot space between contours. We have a 1 foot elevation change. And if we divide 1 divided by 10 here, this should equal 0.10, which is basically a 10% slope. So we know that from here to here we have a 10% slope. Now if you're in a wheelchair, that's pretty steep, so you probably want to go much lower than 10%. The second step that we needed to do was to determine the proposed slope. And if you didn't know what the proposed slope needed to be, so in this particular example, if this was given to us, the client wanted there to be a 5% slope. But let's just say that we need this to be a handicap ramp or a ramp of some sort, and we don't know what the ideal slope should be. So this is where we would go to our slope table and take a look here. Let's see, handicap ramp, so it starts at 0.5% and ends at 8.3. So usually if you want something optimal, you'll pick something here in the middle, and it looks like it's about a 3% slope. So in this case, the client's asking for a 5% slope. So we know that our proposed slope along this ramp must be 5%. The next thing that we need to do is to figure out the spacing for our new proposed contours. So again, we're setting up our triangle. We know that the slope needs to be 5%, and we're just taking a look at the spacing between just two contours, and we know that the elevation change is going to be 1, because if it's just between two contours, it's, the elevation change is just 1. But we don't know what the distance is going to be. So we set up our slope equation, and we find that our distance needs to be 20 feet. And basically what that means is that our contour spacing needs to be 20 feet apart. So going back to our engineering paper here, we know that each square on this engineering paper is 5 foot by 5 foot, which means that each contour needs to be spaced out at least 4 engineering squares apart. Which makes sense, because if you think about it, if these existing ones, single up here, if this is 10 feet and that produces a 10% slope, well, if we want a 5% slope, which is either half or double that, then this is what it would look like here. We have 20. Alright, so now we need to actually grade this in over here. So to do that, one of the tricks that you can do is, we know that the slope here along this ramp needs to be 5%, is I'm going to grade along the center line of this linear object. I'm not going to grade it along this edge and then along this edge as well, because it doesn't really matter. I don't need this ramp to slope to the right or to the left. I just need it to go downwards towards this drainage kind of grate vent thing here, and then into the gazebo. So what does my contour spacing need to be like along this handicap ramp? So we know that the ramp needs to meet up with existing, which is at elevation 1212. So I don't want to really grade that, because I don't want to create a huge 1 foot step for someone in a wheelchair to either have to navigate up or down. So we do want the ramp to start at elevation 1212 and be kind of flush with it. Alright, so one trick I like to do is use something that are called ticks. I know it sounds kind of strange, and this is where I kind of measure out. So okay, 20 feet from here to here is here. 20 feet from here to here is there, and 20 feet from there to there is there, and 20 feet from there to there is there. And I know that the gazebo needs to be sitting on flat terrain. So I'm just going to concern myself with the ramp for now. So I've created my tick marks. I know this is how far apart my contours need to be in respect to this contour here at 1212. So the next thing that I'll do is I'll start sketching in the contours. So starting over here, I'm going to leave this very first one alone. You can modify that one if you wanted to. If you want it to be a little bit flat here before it starts to slope down, that's fine. But I'm going to start right here because I know that my next contour needs to start here. Well, the next contour that is existing is this one. So I'm going to draw in the line that looks like this. And 20 feet apart, the next one needs to happen. And usually when I do something like this, I just start drawing the contours on the ramp part of it first, and then start worrying about connecting it to the existing contours along the side. Finally, I get to the great part of it, and now I know that the gazebo needs to be flat, meaning that all the contours are going to need to wrap around the gazebo at this point in time. So this is where I start grabbing some of these existing and wrap it all the way around. And I pretty much know, because I need to contain all of my grading within the project site, so beyond contour elevation 1200, I know that I'm not on the project site anymore. So I'm going to have to install a retaining wall here. And retaining walls come in different styles. This is just the one that I chose to just put in here. So it kind of gradually slopes out here. So maybe the homeowner puts in some plantings here or something to make this look nice. Just, using my imagination. So you could have graded this either way in exercising and still receive full credit. Anyway, so I have the contours wrap around here, and they're basically just going to stack along this retaining wall. So this is one potential solution that you might have had with exercising. And of course, it's going to vary as long as you maintain this 5% slope along this ramp.